Hello, this is a lesson on probability involving the word or. And before we get into the mechanics of doing probability with the word or, I want to show you some set notation so that you understand why we're doing what we're doing. Part of making math easy is understanding why you're doing it, and then the mechanics make sense. So, the union of sets, which is a capital U, is a collection of elements from several sets. So if we're taking the union of sets, we're collecting all the elements into one set. So union and intersection are two different things, and today we're talking about union. When there's a possibility of one event occurring or another event occurring, that means that both events are an option. So one or the other. Like, I want a sandwich or a salad. Both events could occur. For example, if one number is selected from the set A equals 1, 2, 3, 4, 5, 6, 7, 8, that is a set because it has these little curly braces here, shows that it's a set, and then the capital letter is naming the set. Find the probability that B, the event that the number is odd, or the event C, that the number is a multiple of 4. So we have two different events here. They're describing two different things, and I'm saying find the probability of event B or event C. And like I said earlier, I can show you the mechanics of this, but I want you to understand why the mechanics work. So if I look at just the event B, and I write the elements in that set, event B is the number is odd. So let's write the numbers that are odd from set A. That is 1, 3, 5, and 7. And then event C is that the number is a multiple of 4. So multiples of 4 would be 4 and 8. So we have these two different events, and if I were to take the union of these sets, then that means I will just join the sets together into one set. 1, 3, 4, 5, 7, and 8. I just put them in numerical order because that's easier for me. Let's talk about union for a second if you're not familiar with sets. If you think about union, I've talked a little bit about it already, but if you think about union like a marriage. So two people get married and they both have items in their house that they each own. So their sets are the two different houses, and then when they get married, they have a union together and they bring all the elements of both houses into one house. So you might have two sofas or you might have two casserole dishes or something, but you take all these items and you put them into one house and you have this union. That's what a union is for sets. You take all these pieces of furniture and you put them into one house, and that is the union of two sets. Okay, so now I have this new set called a union, and I'm finding the probability of this union happening based on my universal set A. So I haven't mentioned that yet in this video. A universal set is like the beginning set that has all the elements in it. So A is my universal set. The probability of my union happening represents 1, 2, 3, 4, 5, 6 items out of the total from the universal set, 1, 2, 3, 4, 5, 6, 7, 8 items, or elements, I should say. So there's a 6/8 chance of the union happening. I can reduce that by 2 to be 3/4. So there's a 3/4 chance of the union. Now, let's take a step to the side and look at something a little bit different. The probability of set B happening represents 4 of the 8. And the probability of set C happening represents 2 of the 8. I'm actually going to keep the unreduced form because it'll be easier to add when they have like denominators. And then if I do the probability of B plus the probability of C, then I get 6/8. Does that look familiar? So when you're finding the probability of a union, you're actually adding the two probabilities. So a union is associated with or, and or is associated with addition. So when you see the word or in probability, you're adding two sets with a union. Isn't that so neat? All right. When two events A and B are, this is a new word, mutually exclusive, they have no elements in common. So mutually exclusive means they have nothing in common. If we look at the two sets up here, B and C, and look at every element, the two sets have no elements in common. Those two sets would be mutually exclusive. So if you were to have a Venn diagram, the two circles would be totally separate. They have no overlap, mutually exclusive. When two sets are mutually exclusive, you can add their two probabilities to find the probability of A or B happening. And so that's just a definition, and you can see both here. Probability of A or B means that you're adding the two probabilities, which is the same as the union of the two sets. So very exciting. I love that. Let's look at a couple examples. Find the probability of drawing a king or a 4 from a standard deck of cards. So I have a picture down here of a standard deck of cards. You cannot both be a king and a 4, so they are mutually exclusive events. The probability of finding a king or a 4 means I'm going to find the probability of a king and add it to the probability of a 4. Super simple. We're just adding. So king, there's 4 out of 52 cards that are kings. 4s, there's 4 out of 52 cards that are 4s. Lots of 4s here. And if we add those, they already have a like denominator, so we can add their numerators. And then reduce by 4. There's a 2/13 chance of drawing a king or a 4. So that means that it's not very restrictive. Like if I were to say and, a king and a 4, my probability would go down because that's pretty restrictive. It's very specific. But if I say, I just want a king or I want a 4, either one is fine, it doesn't matter. That makes your probability be higher because there's a higher chance of that happening. There's 8 cards out of the 52 that represent a king or a 4. In some cases, the sets are not mutually exclusive. That means that the two sets have elements in common. So for example, if we were to find the probability of drawing a red card or a king from a standard deck of cards, there is some overlap here. So let's look at the cards. Red cards or a king. Well, there's some overlap. So these are not mutually exclusive. The number of red cards, there's half of them, but I'm going to write the number, 26. The number of kings, we know there's 4. How many kings are also red? 2. So since there's an overlap, then we're counting them twice. I counted them in the red cards and I counted them in the kings. So there's this overlap, and I don't want to include that overlap in my computation because then I'm counting it twice and now my probability is off. So we will subtract out the overlap. We don't want to count it twice, so we're going to subtract it out. So the probability of drawing a red card or a king, whoops, and then we have to subtract out the overlap. So you can see that this or translates to addition because it's a union, but I have to subtract out these two cards that are red kings. So this overlap, those are the red kings. Okay, probability of red cards, that's 26 out of 52. Probability of a king, that's 4 out of 52. Subtract out the overlap. And since we have like denominators, we don't have to find a common denominator. So we leave the denominator the same, and then we do 26 plus 4 is 30, minus 2 is 28. And then I can reduce by 4, and we get 7 over 13. So for events that are not mutually exclusive, we add the two events and then we subtract out the overlap. So that's a rule. You don't have to memorize rules in mathematics if you understand the concepts behind it. So if you can think about it logically, the rules make sense and you don't have to memorize. We'll do one more example and then we'll end the video. Find the probability of drawing a face card or a black card from a standard deck of cards. A face card has a face on it. So let's look at the standard deck of cards. Let me erase this. Your face cards are your Jack, Queen, King. They all have faces on it. So your face cards are 3, 6, 9, 12 cards, okay? And then it said black cards, so 26 of them, half of them, are black. Let's keep that in mind for this example here. Number of face cards, we said there were 12. Number of black cards, there's 26. Are any of the face cards also black? So anytime you're doing probability of or, you have to make sure there's no overlap. So go over here. Are any of the face cards also black? I would say these are. So that's 1, 2, 3, 4, 5, 6. 6 of the cards are being counted twice in our computation, so we need to write that number down. Anytime you have or, you need to look for overlap. So the probability of finding a face card or a black card, you do know that or means add. We know that there's 12 face cards, there's 26 black cards, but there's 6 of them that we don't want to count twice. We have a common denominator. Now we do 12 plus 20 is 32, and reduce by 4 to get 8 over 13. And that's it. That's how you do probability with or. I hope you enjoyed the lesson. If you have any questions, please email me or comment below, and I will be so happy to help. Thanks for watching.